Hello and welcome to the Mathematica training video, Reading Error Messages. This video will explain how you can read an error message and how you can use it to fix your code. An error message appears when the code you have typed has a syntax error. This means Mathematica can't compute your code. However, if the code computes but is not doing what you want to, there would not be an error message. This is because the code is syntactically correct but logically incorrect. The error message shows up under the code after running a faulty script and can give hints as to why the code may not be working. It contains two sections. The first part, in red, is stating what function was not able to run. The first error displayed here is for the command set, which means Mathematica was not able to set the value of something. The next one could not run the plot command. This part of the error message is helpful when we have lines of code that include multiple commands and we don't know which one failed. For an example, if we run this third line, we get many errors. We can see the table function is not working correctly. The general error is just telling us it's not showing any more errors for the table command, and the list plot is failing as well, probably because of the table command. The second part of the error message explains why the command could not run. This part can be confusing to read, but as long as we know what we're looking for, it's very helpful. This will be explained further in the video. Sometimes a command will run seemingly blank with no error messages displayed. For example, this manipulate line is not plotting what we want and not displaying messages either. However, on the right, the kernel is red with a little plus symbol. Clicking this plus symbol brings up a separate window, which is a display screen for messages. When we click the plus symbol, it adds these messages to the display screen. We can see that if we press the plus symbol again, it displays these messages twice. If you want to see just the error for that code, delete all messages and then click the plus symbol again, and it will only be the messages for that line of code. There's a lot of information hidden in an error message, so it's best to search the message for key phrases that tell us what we did and what Mathematica wanted us to do. Let's look at our examples from before to try to see what the error message is telling us and use that to fix our code. In the first example, the error says it was not able to set pi because the symbol pi is protected. For more information on protected elements, reference the video linked in the text. Something to note is that the error is using this symbol for pi where we typed pi in text. To see why this is, we can run just pi and see Mathematica outputs the symbol for pi. If we display this as a number, we can see that there is the value for pi. So we have to change our symbol because the pi we have typed is already used by Mathematica and cannot be set to a number. Typing pi with a lowercase p should fix this problem. Let's look at our second example. In this second example, the error tells us that Mathematica could not complete the plot command. The statement, plot called with one argument, is telling us we tried to use plot while putting one input or argument inside of our command. The second statement, two arguments expected, means plot command needs two inputs to work. To see more information about a command, we can enter a question mark before that command. Doing this for plot shows us that plot requires a function and a variable from its minimum to maximum. Our code earlier has a function but not a variable. If we insert this into our code, it gives us a nice plot. In our last example, the table command was giving us a lot of trouble. It says that -7 cannot be used as an iterator. It's hard to tell what this means, so we will look at the inputs of the table command. The first line explains that table makes a defined number of copies of the expression that we have put in. If we try to run our code with that, this is our expression, this is our number, it gives us a blank graph. To see why the graph is empty, we can execute the table command and see what it's outputting. If we do that, we see that there are 7 copies of x squared and x to the 1/2. However, listplot will not be able to make a graph unless it's given numbers, and these are expressions. So looking at the second example of table, it will list the values of an expression, changing the value of I each time we calculate the expression. We want that because it will give us values of the expression instead of the expression itself. So if we put this into our code, it still outputs expressions and not numbers. This is because we're using x in our expression and we're changing the value of I, so the expression won't change when I is changed. Let's set this to x instead. This way, every time x updates, it gives us values just like we wanted. Now this works, but originally we wanted to go from -7 to 7. Referencing the third example of the table command, we can change our code to go from a minimum of -7 to a maximum of 7. So let's try to do that down at our original function. We go from -7 to 7. We can see it outputs numerical values from -7 to 7. If we put this in our list plot, we get a nice graph with the points from -7 to 7. However, we notice that x to the 1/2 is giving us complex numbers for any x value that is less than 0. None of these values will actually show up on the plot. So this is the list plot from 0 to 7 and not -7 to 7. This is an example of Mathematica running code that you typed, but not what we want. It's important to always verify that Mathematica is outputting what you actually want it to output. Sometimes, the error that comes out is something we don't understand. An example is shown here. The error for this show command tells us it could not combine the graphics, which does not tell us very much. When we click on the plus symbol, it reveals a long list of confusing errors that don't tell us that much either. So, if we click on these 3 dots next to show and click on the first selection, it shows us more information for the specific error we have. It gives us an example of other code with that error in it, and it shows us how they fixed that code. If you're having difficulty with your code, you can always go to the Math Lab for additional help or message the consultants on Google Hangouts. Thanks for watching, and be sure to check out the other videos on our YouTube page.